Good afternoon, everyone. Today, our topic is about the metal. We talk about the metal as architectural material today. What is about the character of a metal? It is low maintenance and durability, and also it is clean look. It has the various uses in architecture field from the structure to the finish grading. So let's talk about the metal extraction process. The metal compound is separated from the earth's material, specially extracted from the ore. So you can see this ore, and you can just get in the metal compound after purifying the ore. Okay, then actual metal product extracted by the metal compound by using the smelting method. Okay, so what is about the smelting method? This is a process to get the pure and strong metal, which is extracted by reducing carbon rate. So when you just get in the metal compound after purifying from the ore, it has some carbon content. To reduce the carbon content, which is the smelting method, to getting the metal product. This pure metal product is stronger and the pure. So that's why you have to reduce the carbon. And also we talk about the later of this lecture. Depending on the carbon rate, you can determine the strength of the metal. So I'm just gonna bring the short documentary clip. It is the movie to be understanding about the smelting and metal extraction process. So let's watch this video and talk the next topic about the metal.
Few fireworks displays are more spectacular than the drama that is steelmaking. The story of hot metal and cold steel is fascinating from start to finish, especially when seen through the experienced eyes of United States Steel. For our company, the story begins with a blast. As rock explodes and the raw materials of steel are tossed from the earth. The rock is taconite, and the prize inside is crude iron ore. We get at it by grinding the rock to powder and separating the ore with powerful magnets. Then we form and heat the ore into marble-sized pellets that will later be converted to iron. From bituminous coal, we create coke to fuel the iron-making furnaces. We crush the coal, seal it in airtight ovens, bake for 12 to 16 hours, and remove it from the oven as solid carbon fuel. The fuel and pellets come together in the blast furnace, where we add just enough limestone to remove impurities. From below, a continuous blast of superheated air combusts the coke, intensifying the heat and changing raw materials into molten iron. Sometimes more than 9,000 tons of it a day in our largest blast furnace, where it reaches a temperature of 2,700 degrees Fahrenheit. At regular intervals, we tap this blistering brew into giant submarine ladles that ride on rails to the basic oxygen shop, where iron will be turned into steel. In this fast-paced sequence, up to 250 tons of steel can be made to order in less than 45 minutes. We begin the steel-making process by dumping recycled steel scrap into the basic oxygen furnace and adding hot iron. Sparks steal the show when high-purity oxygen is blown into the mix at supersonic speeds and molten iron becomes molten steel. Now we're ready to create the custom blends that make steel the most widely used metal on the planet. In fact, we produce over 1,500 different chemistries to meet customer demand for cutting-edge, value-added steel. Look for another show of sparks as we tap molten steel from the BOP vessel into a ladle. Then, for most of our steels, it's on to the vacuum degasser, where they are made highly formable. The focus then shifts to forming and finishing, which determine even more of the steel's characteristics. The first step in this sequence is to position the ladle above a massive tundish or funnel that feeds a continuous caster containing molds that shape the steel. The molten steel, now at 3,000 degrees Fahrenheit, is channeled from ladle to tundish to caster, where it cools to a red-hot solid. The shape of the mold determines the shape of the semi-finished products that come out of the caster. And since most U.S. steel plants make sheet products, most of our casters output slabs, typically 8 to 9 inches thick and 3 to 5 feet wide. As they exit the caster, slabs are cut into sections up to 40 feet long and stacked to await further processing. Then it's on to the hot strip mill. This is where we begin transforming steel slab into steel sheet. Slabs are reheated to 2,400 degrees Fahrenheit and descaled before running through a series of roughing stands that make them thinner and longer. Then they cycle through finishing stands where they are rolled even thinner. Finally, they are cooled and rolled into coils that may be thousands of feet long but only fractions of an inch thick. A far cry from the chunky rectangle that came out of the caster. And the entire process is untouched by human hands, controlled instead by operators using state-of-the-art automated equipment in pulpits that overlook the action. Next, we move to the pickle line, where coils move through an acid bath that cleans the surface. Some of the emerging coils are shipped directly to customers as hot band. Others are destined for applications that require special finishing, beginning with cold rolling to make them even thinner. At that point, coils may be shipped or go on to one or more additional finishing processes. Coating to make the steel resistant to corrosion. Tinning to further reduce the gauge and add the tin coat we commonly see on canned goods. Annealing to make steel that is easier to bend and form. And tempering that uses special rollers to add hardness and create surface textures and other special finishes. In fact, many of our products leave the finishing facilities as the industry's newest superstars. Lighter, stronger, highly engineered, formable steels that were unheard of just a few short years ago. No wonder the story of steelmaking stays so fresh, with innovations that guarantee something new to see in each showing. With product placements in our homes and high-rises, on our highways and in every other part of our daily lives. And with a cast of thousands who continue to improve and perfect every step of the steel-making process, from shaped pellet to shipped coil and beyond.
So now you're understanding how the metal extracting from ore and how we making the metal product from the video. The metal product are combined with alloy to making the better quality. When metal mixed with alloy, you can get in the superior quality. Depending on the alloy content, you can deciding about the metal type. It has different strengths depending on the alloy content. We'll discuss this issue later of this lecture. What is about the metal characteristic? So metal has the ductile and lustrous and conductivity. The ductile, it can deform without losing any strength. And lustrous, it has the shiny appearance. And conductivity, it is good thermal and energy transferring material because it has the good conductivity. It is the good transferring heat and electricity through the metal product. So next one, the metal is a strong and durable material. It becomes a popular material to build the big scale building and the monument because of durability. So you can see this Washington Monument. In the top of the Washington Monument, you can see the aluminum cap. This aluminum cap is installed in 1884. The aluminum cap on the Washington Monument is still in the service. It means the metal is very durable. It is still alive and then without any maintenance because about the metal. So even you can just kind of see that the Washington Monument, the aluminum cap from the Spider-Man Homecoming movie. So metal characteristic, the metal can be used as the various architecture, the material, because it is easy to form and it is strong material. So it is high strength comparing to the weight. And then it is also malleable, it means it is easy to make in the various form. It can be formed into the variety of the shape because of the malleable and the strength of the metal itself. But it also having the limitation. The metal is very sensitive to the temperature shift. If you have extremely different the temperature, you can see that this crumpling over the metal if you use the very thin the metal thickness. It also very good conductor. It means it is easy to losing the thermal energy from inside to the outside because about the metal is a good conductivity material. Next one is oxidation and oil canning. Oxidation can be happening if it fail the coating. Okay, so that's why when you're using the metal, you have to be checking about the coating if your metal tended to oxidating. The metal sheet comes in a standard thickness, which is the gauge. Okay, it has the uniform thickness and it can be measured by the gauge. Okay, so you can say, rather than we can say the actual the millimeter or inch, you can say 16 and 18 gauge because it's too thin for the 16 gauge. It's hard to remember about this dimension. But you can, of course, you can open this manual book. You can easy to know about the sheet metal with the standard thickness. You can see the gauge here, and you can find out the actual thickness per each the metal type. So you can see the brass and copper, aluminum and zinc. It has a little bit different thickness per the gauge. Okay, so that's why you have to know about the gauge for the thickness, and you have to also know about the metal type to find out the proper thickness of your project. Now we talk about the ferrous metal. The metal can be categorized by ferrous metal and non-ferrous metal. What is different between the ferrous metal and non-ferrous metal? So let's look at the ferrous metal first. Ferrous metal contained iron. You remember if you have higher iron content in the metal, it can be stronger than the less contained iron metal. So from this region, ferrous metal is contained iron. So it is mostly using the structure applications. Okay. So steel and iron alloy is the strongest material. It is commonly used in building construction. It's commonly used in the structural application. Okay, because it contains iron. Well, remember about iron tend to oxidizing easily. It's rust easily. So from this region, the ferrous metal is mostly using the structure member because about the strength, but it's also easy to rust. From this region, it is mostly using the internal structure member, and usually covered by finished material over this structure member, or you have to be coating over the metal structure, which is the ferrous metal. What about the non-ferrous metal? It doesn't have the iron in this metal product. They are usually more resistant to the corrosion than ferrous metal. They are still oxidized, but it is protected layer. So that's why this is much better the finish looking compared to the ferrous metal. You can mostly see from the aluminum, copper and titanium, but there's no iron. That's why it's not stronger than the ferrous metal. From this region, it's not used for the structure member. Other than this, it's mostly using for the finish material. Okay, so you can just tend to easier to work than ferrous metal because about the no iron, which is softer but not as stronger than the ferrous metal. So just kind of understanding about what is difference between the ferrous metal and non-ferrous metal. the ferrous metal is stronger because of the iron. Non-ferrous metal is mostly used in the finish because of its appearance, and it is also good to the resisting the rust and oxidizing. Okay, you can see the more example. So now we're looking at some metal working process. First one is punching. Your metal panel can make the various preparation depending on your design purpose. You can see the lots of different preparation type. You can choosing the proper preparation type for your panel if you desire. So I give you some one really wonderful the example using this punched the metal the panel process. This one is the De Young Museum designed by Herzog and de Meuron. It is located in San Francisco. You can see the perforating panel, the pattern over the copper, the metal panel here. You can see that this is all copper panel, but you can see the perforation. The architect is inspired from the natural pattern to design the skin here. This you can see that this pretty random perforation, but when you see from the wall, from the shadow, it looks like the natural, like a tree and leaves, kind of more of the natural kind of feeling, and then natural atmosphere from the shadow through this perforation metal. So they are more inspired from these redwood forest in San Francisco. They just kind of very fascinating about this atmosphere. So they capture the sunlight filtering through the leafy trees, and it affected their skin design to mimic and to provide this kind of atmosphere and the condition. They're using the punching the metal working process. The first one, they actually take a photograph of the image and then simplifying, change it to the black and white, and they just kind of using the scripting tool to designing this punched location basically from their photograph. So from this region, they know about where they can punching it, and then they can just leave it as the plane. So from this process, they can making out this paneling type. You can see that depending on the location from the photograph, it has the smaller opening, the bigger opening. Sometimes they will extrude, and then so you can see the concave pattern. So you can just kind of having the various pattern made from the process. So you can also see that this punching type is also really wonderful way to the contrast with the nature, and then this panel type here. Okay, so next one is bolting. So next metal the construction process, the bolting. The bolting is the join the multiple metal section. When you just connect joist to the beam or beam to the column, we using the metal plate to holding it together. In this case, you can using the metal bolt, and also you can also welding around. So it means if you need a stronger connection, it requires a welding around of this plate. But if you just kind of having the just typical conventional connection, you need a bolting connection. But you have to be checked with a structural engineer. Structural engineer, sometimes they require to welding around to making the stronger connection between the structure members. In this case, you have to be welding around. So weaving, the metal is also possible to weave in the manner of fabric. It is possible to make the metal weaving curtain. So you can see that this one is like a weaving, and then it is like a curtain which is made by the metal. So it is called a metal curtain using this weaving technique. So you can see that this is one wonderful example here. So you can see the project using the metal chain curtain facade. Museum has the smooth and elastic metal curtain skin over the solid concrete block. It blurred boundary between public landscape and actual program. It is Gukje Gallery designed by Soil. So this is a kind of elastic, the metal curtain. So means they making out the foam and easy to making out these fabric like the metal elevation skin design from. So you can see the better image here. You can see the extrude out the metal. It makes out these beautiful kind of the beautiful form basically from this metal curtain design. So how it works, how they actually making this elastic kind of metal curtain skin. They using this system here. The first one, they anchoring the bottom of the slab, which is this is ground level and then this is slab edge. They actually anchoring the metal curtain at the bottom of a slab here, and then they tensioning this fabric, and then this is extrude out, and then this is keep tensioning around, and the top of the slab, which is the loop condition, they using this spring here. You can see this spring. This spring provide the tensioning to making this elastic form. Depending on your tensioning requirement, some part have to be very tensioning to making a more tensional the form, but some part a little bit release and relax. So in this case, you can actually control this tension and relax the level basically from this spring and connection from the top. So bottom is kind of fixed it, and you can actually controlling these tensioning point from the top. So from this region, is it making out this tensioning and elastic the fabric layer from the building using this metal curtain system. Next one, you can see the casting. To make desired metal product, you can use the casting method. Casting is the mostly used for the making complex shape. You simply making out the form and put the hot and melting the metal, and then after cooling down, you can get in the desired form. The liquid metal is poured into the mold that contain the hollow cavity of the desired shape, and is then allowed to cool and solidify to getting this desired form. So next we can see the rolling. The rolling, you can see this is a
to cold form a C shape. Thin metal sheets are rolled through steel forms until the desired section is achieved.
The metal is gradually deformed into the rounded profile or thinner thickness by repeatedly passing through the series of paired rollers. So it means we can just kind of prepare these thin the roller metal panel. This one simply passing through the roller. You can just making out the thinner metal plate. Also depending on the roller type, even you can just making out having the forming kind of metal product you can get from the rolling process. Next one is extruding. The extruding is a process used to create the object of the fixed cross-sectional profile. So depending on this section, you can get in the desired form. Simply, you have the metal product here, and then it pushing from the one side. Then this metal product, the passing through, and then passing through the desired section, you can get in the proper form here. So that's why you can see the lots of different the form and pattern you can get in from the extruding. You can just simply think about the toothpaste. When you're just kind of pushing from the end, and then it is coming out basically from the end of the toothpaste. So depending on this end of the toothpaste pattern, you can get in the desired form. Also, metal is cutting by contracted jet or water or the frame of a torch. So you can just even getting some proper length, also proper pattern. You can just using the cutting method using like a plasma cut or the water jet, or simply just using the torch. You can just get in the proper form. Nowadays also you can using the 6-axis the cutting. It means the 6-axis you usually consider about the laser cutting is 2D, which is a 2-axis, X and Y. But 6-axis can be Z-axis, and then they are more free to making out the form. From this region, using this 6-axis, the robot, you can just get in a more 3D form. Or you can use the 2D, you can just get in a more 2D form here. So next one is welding. The welding is the fabrication process that join the material. steel surface can be joined from the electrode. You can see that this is electrode, and they just kind of need to connect the metal to metal strongly. You can just consider the electrode using the welding process to making out the foam. So now we talk about the metal product. What is about the metal product in architecture industry? So iron. So let's talk about the iron alloy that contain the carbon according as the carbon content, the steel types, and the strengths are decided. So depending on the iron, the content, the carbon content, you can deciding about the different strengths of the metal product. So more proportion of the carbon, more carbon means you can increase the hardness and brittleness of the iron alloy. If you have more carbon, it means you can get in the stronger metal. So usually cast iron between the 2% to 4%, more than 4%. But medium and high carbon steel is less than 2%, and mild steel and even the less carbon content, and wrought iron even the less carbon content. Okay. So just simply summarize it. Greater proportion of a carbon generally increase the hardness of the iron alloy. So let's look at the cast iron first. So cast iron is strongest steel type, having the 2 to 4% carbon. It has the strong compression, but it is the less strong in tension. Okay, you remember the compression is this forces and tension is this forces. So during the 19th century, the cast iron was used structurally and ornamentally, and is often constructed building entire facade. When you go to New York, in Soho area, they have a cast iron facade here. So from this region, it's a very popular material to use in the structure and this ornament purpose. However, it is also brittle, which is sudden failure. The metal itself is too strong. It means it doesn't have any malleable. So it means when you're having the weather change and then temperature change, it actually affects the strength. It's because about the cast iron is the higher carbon content. It doesn't have any malleable impact. From this region, you can see the sudden failure in a certain point. Okay. This is a disadvantage of the cast iron. What about the medium and high carbon steel? It's less than 2% carbon. It has the good compression and tension. It is strong, the metal product. However, it's too strong because of the higher carbon. It's hard to making out the foam. From this region, you can mostly find out the boxy, the building, because it is hard to making out the complex foam from this medium and high carbon steel, because it's hard to cut and hard to bend and difficult to welding together. So next we talk about the mild, the low carbon steel. The low carbon is the most popular alloy for modern and contemporary structural steel. It is possible to make in the barrier steel structural foam. It covers from the flat sheet metal to the structural beam. It is equally strong in tension and compression. You can see this one is the highly ductile, and also it is strong material. It is easy to weld. Comparing to the high carbon steel, it is available to making the complex foam because of the ductile and easy to weld. From this region, and contemporary modern architecture is becomes more complex. It means it requires more complex metal structure foam. From this region, the carbon steel and cast iron steel, it is have a limited to using in the contemporary the metal framing structure. From this region, the mild carbon steel, low carbon steel is popular to using in these complex the contemporary architecture foam. It is equally strong in tension and compression, also ductile and easy to weld. So from this region, the mild and low carbon steel, it is the most popular and most typical the metal product in the industry for the structure member. So just kind of understanding about that. You have to know about what is about the mild, the low carbon steel, and why it is the most popular in our industry. You have to be understanding about the concept. So next one is wrought iron. So wrought iron is the iron alloy with a very low carbon content. This is the most common steel type before introducing mild stone. It is strong in tension but weaker in compression. It is also very malleable, easily shaped, and also very soft material. From this reason, the wrought iron is used for the steel sculpture and ornament. Because the Eiffel Tower, it is made by the iron alloy, it is available to making these complex ornament form because it has malleable and soft the characteristic of the metal. So let's looking at some of our precedent. This is a very famous historical precedent to understanding about how they using the metal their project. Our first project, the Daimakseong House, designed by Buckminster Fuller in the 1945. The first project is Daimakseong House. Daimakseong means dynamic, and this means maximum, and this is a tension. So one more time, Daimakseong means dynamic, maximum, and tension. Why they designing this UFO looking house? After World War II, Buckminster Fuller wanted to make a mass-produced and innovative housing type in post-war period, because after war, the people just coming back to their home country from all around the world during the war, right? They just kind of go to military and then they just come back. But they don't want to live in a city because they just kind of want to have in the classic American housing type, because they are tired of the military things. So they just kind of want to have an own yard. They just want to have in a more family-oriented space. From this region, the Buckminster Fuller think about. So after World War II, they required lots of the housing. So means they just consider about how they actually making this housing fast and faster. So from this region, they consider about the free fabrication. Every house made from the factory. It is factory manufacturing kit and assembled in a site intended to be suitable for any site or environment. So this is kind of their vision why they using the multi-production, the housing type. So this metal still is available to making this free fabrication, the housing, because this is simply prepare the metal, the assembly kit, and then from the factory, and then it is easy to build up on the site. So you can just kind of having the base, and then just framing and adding the finished cladding and simply adding the top of that. I heard it's kind of only maybe 1 or a few days to complete the one house, because everything the free fabricating from the factory. I believe it is the very first the free fabrication architecture in history. So Buckminster Fuller have a huge kind of innovating thinking to provide housing after World War II. So you can see the designing here. The key design consideration was easy of the shipment and assemblage. Its principle of the doing with less weight, less time, less effort to assemblage. And it needs to have a level of functional performance as well. The systematic the mechanization of the home, the Buck is incredibly futuristic outlooking. They ignore any past conception of what has been characterized the homely, right? So it means after World War II, they just experienced the war, but they just kind of having a more cozy feeling from the home. So from this region, they don't want to live in these metal and futuristic housing. Rather than this, they just kind of want to just kind of find out the house who they growing from the childhood. So that's why they just kind of want to live in the more gable loop, just a typical type of the housing in suburban area, rather than this futuristic home. But the Buckminster Fuller's idea is very innovative, and then just kind of giving the new way of thinking how we consider about the matter, the free fabrication system, and how we can shipping from the factory to build up the housing in a site. I think that is very innovative thinking, And the housing itself have a lots of interesting kind of idea, even we can see in the contemporary days. So let's watching some of a video to introducing about the Daemakseum house, and then let's looking at the next example.
At Wichita, Kansas, in the very center of the United States, the housing problem brings out a circular dwelling built of aluminum and plastics. Instead of a foundation, this cornerless cottage is suspended from a central mast of stainless steel. The engineering principle, with the safety factor of a suspension bridge, permits new ideas like a revolving roof, which gives a complete change of air every 6 minutes. Using a model, the inventor shows how circular design makes the best use of floor space. Using new war-developed lightweight metals and prefabrication of parts by mass production, this home of living room, 2 bedrooms, 2 baths, and a kitchen can be economically produced and will contain a compact heating and air conditioning unit. House hunters find many pleasant surprises. The clothes closet appears with a flick of the finger. And a built-in dust-proof hat rack. But most interesting of all is the conveyor belt linen closet. Recessed in the wall, the press of a button rotates the conveyor shelves. A roundhouse may seem strange, but in a housing shortage, people are giving attention to all new ideas.
So next project, the Eames House case study number 8, designed by Charles and Ray Eames in 1949. This project represents mid-20th century modern architecture. It serves home and studio, which is their studio, the office studio is here. You can see the very clear structure system. Everything just follow the grid system, because the metal product at the time is kind of when they following the grid line, it is much easy to build, and then easy to making out some structure to reduce the actual construction cost as well. So the idea of a case study number 8 house represent modern life movement in 1949 after World War II. It elaborate functional requirement and clear structure. Architect developed design that met the requirement using the modern material and construction process. So you can just see how they actually control the structure system and the program. So they throw the grid line, and then every single the arrangement of the project, the following this grid line. Okay, so even there the paving size and structure grid size, and then their room size, everything following from this grid to the making out the space. Okay, so it means they just using this functional requirement and clear structure is available to build up the project here. So next example, you can see the project locating on the slope with the retaining wall. So you can see this is the retaining wall. You can see the retaining wall here, right? And the 17-foot tall facade is broken down into the rigidly geometry following the structure grid. So this is the main structure, and then they just kind of designing the metal framing system using the truss system. This is the main skeleton, and then simply they can add the ceiling and this crading system at the elevation. So you can see that this is a framing structure, and then truss system, and you can see the glass, but sometimes they actually having the crading here. So simply just kind of inserting into this metal structure. So that time though, after World War II, architect more concerned about efficiency and more about the cost reduced the structure method. So this house just kind of simply following this gesture, effectiveness of the structure, and then you can reduce the cost, and also you can reduce the construction, the period. So they are more to consider about this effectiveness to build up this house. So from this region, metal is perfectly fitting to the making out the structure, using the philosophy of this house, which is effectiveness and the cost reduction, and then the construction period, the reduction. Okay. So you can see the actual photograph. You can see the Charles and Ray Eames here. And then this is a clean and pure structure grid. You can see the truss, and then you can see the beam and column. Okay. So this one is simply just kind of following the skeleton, and you can see there's a retaining wall here because this is a sloped area. So this is the main, the skeleton. It's very clear, right? It's simply making out the three-dimensional grid and simply adding the crading and the grading system into that. So you can see the finished image, and then even inside you can see the clear structural vision. You see the all column and beam and metal decking, and then also you can easy to articulating the solid and void, which is a solid and glass. So you can just kind of simply following this rhythm to making out this house. So great balance between the solid and grading panel on the elevation, right? And you also can find the structure grid from the inside and outside. Let's watching the video to shows the case study number 8. So let's view the space from this short video, and then we talk about the architecture stereotype. So let's talk about the architecture steel type. The first one, we're looking at the weathering steel. What is about the weathering steel? What is about the weathering? The weathering is surface oxidation or rusting effect if exposed to the weather for several years. The weathering steel is popular usually using the outdoor sculpture. You can see the Chicago, this Picasso sculpture, and architecture facade for the rustic antique appearance. So from the decision, the architect loved using this one to provide more antique and more cozy feeling from the project. Also, it's very attractive because through the time, these materials keep changing some texture and then color and appearance. The weathering steel, it is the best known under the trademark Corten steel, which is the Corten steel. You probably heard about it. It is using this weathering effect to the making of these crading or sculpture pieces. So simply understanding about this patina process, the passing time. So when you're having this orange color 15 days. But when you having the 2 year, it's totally changed the color. And after 40 years, it changed color here. So I mean through the time it keeps changing the color and texture. It's very interesting, right? It's also very pretty poetic way to delivering about your idea how your facade and elevation skin is changing through the time. But you have to be know about the when you want to stop this patina process passing the time. So you just kind of you liking about this color, and then you don't wanna making this color. In this case, you can simply coating over the weathering metal. It means after that, this patina process is just stop from the 6 months, or 2 years, or 5 years, whatever you want, right? So after coating it, so this will just stop the patina process. So means you can just kind of also the contouring about this weathering process from the treatment of your material. Next one, you can see the actual example using this weathering steel. This is the University of Iowa Art and Artistry designed by Stephen Ho. You can see that this weathering the metal, the panel. You can see here, right? So it is the patina effect is well balanced with the structure and metal color, which is orange. Also their interior part, they matching the color, so that's why they are trying to making out from the outside inside the fluently flow from the outside to the inside using the similar color outside and inside. However, the weathered metal can be stained around. You can see there were lots of stain around. It needs regular maintenance to avoid the stain issue. It's hard to get out of the stain. So if you just kind of get out of this one, you mostly have to be repressing this concrete panel. So from this region, this is a very difficult to maintaining it because you can keep seeing this stain around. But you don't want to make this stain. You have to be avoid this stain issue. So from this reason, when you're just using the weathering steel, you have to be maintained regularly. Next one is copper. It is soft and malleable and ductile metal with a very high thermal conductivity. It's not great for the thermal transition perspective, but still it is pretty popular material from the history. It is the human as well as 6000 BC. It used since Renaissance as a looping material. So we already discussed about the looping copper material from the loop lecture. So it is popular the looping material at the time. It is also soft ductile corrosion and resistant patina. So when you see that this copper, it is also weathering effect. So 1 to 3 years you can see this color, but after 4 years it changed to the green color. So it means it is also pretty interesting to seeing the color change through the time. The freshly exposed surface of pure copper has the reddish orange color. However, when it exposed to weather, it will become the green color you can see. I think that is kind of pretty interesting to transition from the orange to the green. But when you see these types about the interior space, interior is not a weathering effect because it's just kind of keeping the weather out, right? It's just kind of inside. But how they actually making out these types about the weathering still inside? But you want to make this green, you have to wait in the 30 years? Maybe not, right? It's hard to wait in the 30 years to making out this green, the copper panel. In this case, you can use the chemical. So when you having the chemical treatment over this orange copper, it is kind of very fastly changing to this green color. So that's why when you're using this orange color and the green color together, when you're having the chemical treatment, you can just get in this spectrum, nice kind of a pattern you can get from the inside as well. So you can just waiting to the 30 year to getting it. You can see the processing of the patina. It's kind of one of the interesting and poetic way. But when you just want to having this green color right away, you can consider having the chemical treatment right away. You can have the various color and texture depending on the weather type. The weathering impact can be made by the natural process or chemical color. You are using a different color the texture depending on your design purpose. As we discussed from the previous, how you can get in the green color right away, you can think about the chemical treatment. Depending on the chemical treatment, you can just get in the lots of interesting pattern for the metal design. Okay, so means you can just kind of using this type of method, you can just make out a very unique elevation or interior wall you can design. Next material is aluminum. Aluminum is the second most commonly used metal in construction. It is also great resistant to corrosion. In the 1920s, aluminum began to popular to use in architecture industry. At the first time, the application were primarily oriented toward the decoration and detail and Art Deco structure. However, the 1930s, the Empire State Building actually introduced aluminum for the major structure. So aluminum is expensive than the other material. However, its strength and also it is great resistant of the corrosion. So from this kind of character, Empire State Building using this aluminum for their construction. Today, aluminum is more recognized as one of the most energy efficient and sustainable construction method. It is recycled material. It can be recycled between 50 and 85% in a current days. I think this is pretty amazing. After that, they recycling and reuse it with a different way. So you can see the lots of different the aluminum material. You can use this one as the cladding, and you can also consider as the interior, the feature, also consider as the structure member as well. It is aluminum composite panel, because you remember the metal itself, the thin metal is very sensitive when it has the temperature change. It's easy to crumpling, you remember. From this reason, nowadays when you're using the panel, they having the some of the backing here. It is called as the density polyethylene, the core. It's like a sponge-like. It's kind of a sponge-like kind of material, and then aluminum, and this is kind of sponge-like material, and then they making the actually composite panel we can call it, and then it used as the cladding structure and cladding finish material. The laminating process is produced on the continuous production line, which result in the flatness and excellent strength. So from this region, when you're just using the aluminum itself, it is weak, right? Because of the very thin panel. From this region, when you add in this core and then laminating together, you can get in a more durable the material. Again, you can also protect this crumpling issue. Next one is zinc. We talk about the zinc from the roof. It is used the Industrial Revolution in Europe as a roofing material. It also used the building cladding. It also surface oxidizing to the self-protecting matte gray finish. So it means to protect oxidization, you have to be protecting the layer over the metal surface. It is also very popular, the roofing material. Also it is using for the wall as well. And you can see the lots of different color and then different finish available depending on the project requirement. You can choose the proper type and proper finish type and proper color for your design. The last metal type is titanium. This long-term use metal material, compared to the other metal. The titanium doesn't accelerating the galvanizing corrosion. It is really good the protecting the material. Is really good the resisting material. It is little heavier than aluminum. However, it's much lighter than other steel material. It is really wonderful finish looking, and it is like a space-age material and a really good the resistant material. That's why you can see the Walt Disney Home, Frank Gehry, and Paul Andrew. I think this is Opera House in China. They're using this titanium. However, it is expensive with a lot of great the feature, the strength, and the good finish, and also pretty light and a good the rust resistance. However, when you compare it to the other metal, it's kind of more expensive than other metal. So it is excellent aesthetic quality and long-term use material. So you can see the lots of possible finish as well. And also you can see the perforated titanium panel between the two glazing panel, which is a sandwiching panel. It is also it works as a shading device. However, it is still pretty expensive than other materials. So that's why, depending on your budget, you should consider about the material selection. Okay, I think today's lecture is about today, and then I think today we talk about the metal process and how you produce the metal, and then what is about the mild stone mean, and then also we talk about the different architecture metal type, and then the production process. We just kind of talk about the very basic idea about the metal product, the metal materiality. But next year, we more to discuss about how you actually using the metal for your construction, how you using the metal for your creating. So more detailed stuff we can discuss next year. But today, just understanding about the concept, what is about the iron alloy mean, what is about the ferrous metal and non-ferrous metal, what is about the metal product, the fabrication process, and what is about the different metal type for architecture industry. So just kind of understanding the materiality and concept today, and the more detailed part we can discuss the next year. Please, you keep going on your lab assignment, but if you have any question about the lecture contents, please stay in the Zoom, we can discuss. Or if you want to meet face-to-face, please let me know, we can make an appointment to meet together to discuss about the lecture or any other topic. Okay, thank you guys.